Hi everybody, welcome to the Why Pure Tech Talk. I'm Mike Carpendale, a field solution architect covering the APJ region based in Brisbane, Australia. Very pleased to be joining you all in Seoul and delivering this Tech Talk today. I've been doing this for a little while now, 25 plus odd years, as you can see from the grey hair in the beard. And I've been doing this across a number of roles. Starting off in the Royal New Zealand Navy, moving into systems integrators, and before joining Pure Storage with Australia's largest telco being Telstra. My focus here at Pure Storage is around the platform architecture space and looking at it from a digital infrastructure perspective, using our products and our services in the on-premise world, and then also extending that into the public cloud space. Today, I wanted to talk to you around CBS and why, what we are doing in that particular space, being Cloud Block Store and how we integrate into the Azure VMware service, the so what, how we can actually apply this in the real world, and then the what next. The first part of this is Cloud Block Store, the why and how, and what we're doing with it in the public cloud service. If you roll back a few years, there is this desired state that a lot of the cloud providers were sort of talking to us about. And it was around this notion of seamless orchestration and bidirectional mobility of our virtual machines. And they could move from the on-premise world into a cloud world or an edge world and then back again. This seamless orchestration. If your virtual machine or your application was stateless in nature, we found that that was going to be very easy. But as these applications and these virtual machines became more complex and became bigger in nature from that data set, we found that data gravity was one of the severely limiting factors with the seamless orchestration and this mobility. The other aspect of that is simply trying to store data in the cloud is different than from in the on-premise world. And then we look at what we have in an Azure environment and also in the AWS environment. We have different disk types across the ecosystems, whether that be standard or premium SSD disks. You also then have this trade-off on choice between capacity versus IOPS, or capacity versus throughput, performance and latency. So there's lots of choices and trade-offs that you have to make and choose in the cloud world. What can Pure do about this? Well, it is about us extending our promise into the cloud from that on-premise world into the cloud world. We are doing that and achieving it via the Pure Cloud Block Store solution, or CBS as we call it for short. CBS is a 100% software service, and that software, the Purity operating system, has been abstracted away from the hardware. The Purity operating system now runs virtually in AWS and Microsoft, and it allows you to consume highly reliable and efficient services, giving you hybrid mobility and protection in the cloud. The added benefit that you have the consistent API and automation approach from an on-premise world now in the cloud world as well. We achieve that via the Purity operating system and those enterprise features that you can see here, whether that's the data reduction and the thin provisioning, or perhaps the replication that you're used to using in an on-premise world, our active cluster for synchronous replication, or perhaps active DR for more continuous replication into the environment. Snapshotting is also a very important feature that we have inside the Purity operating system from that on-premise world, being able to snapshot and clone data sets out incredibly rapidly with minimal overhead on the arrays. And you couple that with our safe mode feature, you now have immutable data sets in the cloud, and this is in Azure and AWS. Let's talk a little bit more around Cloud Block Store for Azure and what the actual architecture looks like. We used to have two models in the Azure environment. We've recently released a new model, and so we have three models for Cloud Block Store in Azure. We started off with our R1 generation models of Cloud Block Store, very similar to the physical devices. Say that was an X50 R3 and then we released the new R4 model. Well, the same has happened here with Cloud Block Store. We've recently released the V20 R2 model, and that is leveraging the new premium V2 disks rather than Ultra SSDs, and a new virtual machine set as well. The architecture for Cloud Block Store is very similar to the on-premise world. We all know and love the on-premise flash array, and we're very familiar with that. Sometimes it becomes a little bit hard to understand what that looks like in the virtual world. Well, if we were to take the controllers, the physical controllers, that is delivered by two virtual machines inside Azure. And these virtual machines are either the D series virtual machines or the E series virtual machines, depending on whether it's an R1 or an R2 Cloud Block Store instance. These virtual machines also have read cache as well as a boot volume. The other aspect that we use inside the cloud is the NVRAM disks. The physical components are translated into two NVRAM disks delivered via either Ultra SSDs or Premium SSDs attached into our controller virtual machines. We then store the persistent data onto 14 disks attached to the virtual machine controllers. These are either Ultra SSD or Premium SSD V2, depending on if it is an R1 or an R2 Cloud Block Store instance. We need some networking inside the environment to make Cloud Block Store work, obviously, and that is management, iSCSI, replication, and system networking with some internet access. There's a few other components that we need for Cloud Block Store to become up and running and available inside Azure, and that's a NAT gateway or perhaps your corporate firewall, Checkpoint Palo Alto, being deployed into the environment with internet access so the Cloud Block Store instance can phone home into Pure One. There's a requirement for Cosmos DB to keep track of the Cloud Block Store instance, the specifications of it, the virtual machine, controller types, the Purity operating system level, and the disk sizes as well. We also use Key Vault to help with the security keys and the encryption at rest of all of the data on those disks in the cloud. The new instance, interestingly enough, is actually using a slightly smaller virtual machine, just a newer type. So we're changing from a version 3 virtual machine to a version 5. We're going from 64 vCPUs to 32 vCPUs. And we're actually achieving higher IOPS and bandwidth performance from this new virtual machine controller type. The other change in the environment is switching from Ultra SSD into Premium SSD V2 managed disks, and this is giving us 70% lower cost. But overall, what we're roughly seeing is a 50%, just short of 50% savings in the underlying Azure infrastructure to run the environment. In this particular graph, lower is better, and our red graph, our red lines, is the new R2 instance based off Premium SSD V2 disks. We can see that it's roughly 50% less than the R1 cost. We can even see that down in the very smaller scale of things, that the R2 array is cheaper than the R1 V10. From a region support perspective as well, we are able to deploy both the R1 and the R2 Cloud Block Store arrays here in the Korea Central region. We don't yet have capability in Korea South, but we're working with Microsoft on that to look at building out additional capabilities and infrastructure there. Should you need DR, the Japan East and Japan West environments aren't too far away, and you could connect the two Cloud Block Store instances and replicate the data set to become highly available across the regions. Let's talk a little bit more about the entry point in TCO for a Cloud Block Store solution. Originally, with the R1 arrays, we were looking at roughly a 95 terabyte entry point into a Cloud Block Store environment. This meant that you needed roughly 95 terabytes for it to be a positive type TCO model. Now, interestingly enough here, not every customer needed it to be a positive TCO. We saw some customers leveraging those enterprise features and using Cloud Block Store with a slightly smaller data set because they wanted to snapshot and provision that data out quicker and provide immutable data sets. Now, with the introduction of the R2 Cloud Block Store array, we can see that 35 TB is that entry point. And the more that you consume in that environment, the more that you save. This is a rough TCO of one of my customers. This customer needed roughly 3 petabytes of storage. We were able to deliver that 3 petabytes on 1 petabyte of storage. And you can see here some significant savings over the first year, just over $2 million. And then if you look at the TCO across a 5-year period on that, some very significant savings by shifting away from Azure Managed Disk into Cloud Block Store instance. So how do we get this ROI? How do we make it better? Well, the first part is around the storage capacity. The thin provisioning, compression, and data reduction capabilities of the Purity operating system are really second to none. Then we look at the storage performance aspect of provisioning the data volumes in the cloud. No longer do we have to over-provision these volumes for performance. We can make them exactly what we need, and sometimes even a little bit smaller because of the efficiencies of Cloud Block Store. There are other areas where we can reduce the overall cost of a cloud solution. So from the compute perspective, what we're able to do is to reduce and use smaller virtual machines rather than these bigger virtual machines that have to be attached into more high-performance disk base as well. The other area is around the networking. Cloud Block Store and the Purity operating system always reduces and compresses the data across ingress and egress of the networking traffic, whether that be between Cloud Block Store instances or from the cloud back into your on-premise world. Shifting less data is great from that overall cost model perspective, especially when you look at the VNet peering charges and the charges between regions. A few use cases that we will talk about now. So on the right-hand side here, we can see the organizations that are looking to consume Cloud Block Store. And then down the bottom, we have got the applications that these organizations are shifting into the cloud for the particular environments. And whether that's production or DR or test, what we're seeing is a large adoption of SQL in here. That is a great use case for us. One of the biggest use cases that we can see on there up the top is a health customer or a healthcare and life science customer in the US. They have moved 11 petabytes of data from Azure Managed Disk onto Cloud Block Store. This was a significant amount of data to move, giving them some significant savings, which was in the order of $10 million US per year. One of the other areas is around optimizing that enterprise storage or enterprise. One of the other areas is around optimizing enterprise cloud storage in that environment. Let's look at it from that storage capacity perspective. The first part is provisioning the volume inside that environment. Say I needed a 4.1 terabyte volume inside that environment. I'm going to have to write that down into my system. But what we're going to actually have to do inside the Azure world is to actually over-allocate that because of the binary scale of those disks. So if it was a premium SSD disk, we would have to provision 8 terabytes. So what we're seeing here is pre-allocated and wasted capacity due to the binary scales, and also wasted money. If we look at this from a storage and performance perspective, say I still needed my 4.1 terabytes of data going into that disk, but I needed increased throughput or IOPS. Well, the way to achieve that is to be over-provisioning that in certain disk types as well. So again, we are over-allocating and wasting money from that perspective. If we were to look at this in the Cloud Block Store world and how we do it slightly differently, we're going to leverage the enterprise capabilities that we have built into Purity around the deduplication, compressioning, and thin provisioning. We will take that data set and we will apply that to it, and we will see a much smaller footprint of data stored on disk. This data reduction capability is going to give us instant savings from the get-go, and then we are going to have some free space savings as well. So some problems are best solved in the cloud, and I say best with Orange and Pure Storage in mind. So from that cost efficiency perspective that I've just walked you through, I think we solved that really well. The other areas are around flexible disaster recovery and leveraging the enterprise capabilities of the Purity operating system inside the flash array and inside Cloud Block Store, whether that be Active Cluster for synchronous replication, Active DR for continuous replication, or the asynchronous snapshot capabilities, and then also Cloud Snap, so that you could potentially take your on-premise data, Cloud Snap it, and have it sitting in blob storage, ready to rehydrate in a Cloud Block Store environment. If we think about it from a dev and test perspective as well, being able to leverage deduplication, compression, pattern removal, thin provisioning in conjunction with the rapid snapshot and clones of your data sets on Cloud Block Store, we're able to increase the time to realization for any dev test type workload. Migrations are really easy with Purity, on-premise flash arrays, and the Cloud Block Store. It's a simple connection of the devices from the on-premise world into the cloud world. We're leveraging replication to push our data sets up there. We're only replicating deduplicated and compressed information, which really helps from that ingress perspective. Potentially, you don't need as much bandwidth replication into that environment. Then also, if you want to replicate between environments, between AZs, between regions, or even back out of the environment, ensuring that it's deduplicated, compressed, and then replicating delta changes only, some significant savings to be had. Trying to protect your data in the cloud is really important as well. We can do that fantastically from the on-premise world with our safe mode capabilities on there to prevent the destruction of our data sets, whether that be from a cyber attack or even just from a rogue admin inside the environment. Safe mode with the multi-authorization, the eradication timer delivers that capability to be able to recover your data set into the environment. And the closer you can recover your data set to the primary source, the quicker you'll be back up and running. Part 2 of this talk is around the Azure VMware solution, AVS, and how we integrate into Cloud Block Store. AVS and CBS are two existing solutions that have come together to deliver improved TCO inside an environment, to deliver those enterprise data management features that we've come to know and love in the on-premise world, and also to deliver risk mitigation to your business as well in the form of safe mode and immutable data sets in the VMware cloud. We're finding that a lot of VMware migrations into a cloud environment become stalled because of the cost model, because it is not as cost effective to migrate my entire on-premise environment, my VMware environment, into an AVS environment. We're also finding that AVS and Cloud Block Store is very capable to help burst those those VMware virtual machine workloads up and down, and then provide seamless disaster recovery, whether that be from an on-premise into the cloud, or to make a vSphere Metro storage cluster with AVS across two AZs. So I talked you through some of the problems and how they are best solved in the cloud from a Purity perspective. The exact same principles apply here across enterprise cloud storage, flexible disaster recovery, dev test, the migrations, and ransomware. If we look at applying Cloud Block Store into an AVS environment, what we're sort of seeing here is an example that I've worked through with one of my customers. The customer had 40 older generation hosts sitting in an on-premise environment. They had 700 terabytes of flash array and they were wanting to exit that data center and move into the cloud. With an AVS service and an AVS only service, that was going to equate to 51 nodes for that environment to roughly get 650 terabytes of usable space. From there, we can already see some number mismatches going on. 40 older generation hosts to 51 newer generation hosts. Put simply, AVS and the HCI nature of the Azure VMware solution, it is what is causing this particular problem. Now, if we were to think about this slightly differently, AVS coupled with Cloud Block Store, when we right-size the environment, we now need fewer nodes, 25 nodes, and roughly 650 terabytes of Cloud Block Store to do the exact same thing and get the exact same outcome. This was giving our customer roughly $400,000 US savings per year. And we can see Emoji Mike likes that on screen. From a region support perspective, unfortunately, we don't have AVS inside the Korea Central environment just yet. That is something that we're working on with Microsoft. And anyone that's out there listening to this wants to move from an on-premise VMware world into an AVS environment, let's talk to Microsoft to bring AVS into South Korea and into Seoul. I've talked to you around the Cloud Block Store capabilities and the AVS, so let's talk a little bit about the so what and the why for this. If we combine all of this, we see this as the foundation for hybrid, to be able to have your on-premise or co-location environment connected into your network fabric and to be able to seamlessly migrate and move your virtual machine workloads from on-premise into a web-scale cloud, or perhaps even out to the edge environment, maybe even into an Equinix bare metal as a service type environment. We achieve that by leveraging the tools and portfolio capabilities from Pure Storage. Evergreen One and our Evergreen Storage subscription service is key to that. Being able to consume storage in that on-premise world and then have the right to transition it into the cloud environment is one of the key aspects here. Pure Fusion and Pure One, from that modernizing your operation perspective, Pure Fusion is going to be overlaid in the Cloud Block Store environment, and you will simply use Fusion to pick and choose the destination for my volume on multiple Cloud Block Store instances. And of course, we have the Purity operating system, which powers us from the on-premise environment into the cloud environment. Now, for those organizations that are looking to modernize their applications, perhaps move into cloud native, Portworx is the key for this as well. If it's a stateless container, that's relatively easy. But as these applications start to evolve and become more complex, stateful data sets are going to need to move from our on-premise environment into a cloud environment as well. And that's definitely one of the capabilities of Portworx and where it excels. And all of this is about de-risking and accelerating your application modernization. And as much as I think infrastructure is cool, the application is really king when it comes to this. And so we don't want to let the storage dictate my application architecture or where my application can be placed. This is about being able to place my application in my traditional on-premise environment or perhaps the VMware cloud environment. Maybe I want to use native virtual machines inside Azure or move that and transition that into a Kubernetes service, eventually evolving into platform or software as a service. We can achieve that across an on-premise world, an AWS or Azure world, and we do that with our Evergreen subscription capabilities, Cloud Block Store, Fusion, and Portworx. The what next in this little talk series? Well, to be able to use Cloud Block Store in an AWS or an Azure environment, it is very simple. Simply get in touch with us for a free trial licensing, and this is free from a Pure Storage perspective and the licensing capability of Cloud Block Store. There is still an infrastructure component cost to running Cloud Block Store in the cloud, whether that be AWS or Azure. You can get in touch with AWS and Azure to leverage their programs around those infrastructure costs as well. You can deploy these appliances from either the AWS Marketplace or the Azure Marketplace. And with inside a few clicks, you'll be up and running with a Cloud Block Store instance, ready to connect that into your virtual machines or your AVS environment. So thanks for joining us today to listen to this tech talk in Why Pure. If you want to learn more about Cloud Block Store, here is the QR code. Get clicking and we'll see you on the Pure Storage support website. Thanks for listening.